Hello, and welcome to the Fiery Color Flowchart 2016 video. In this video, we'll explore the expert color settings on the Fiery digital front end and how these settings affect print jobs sent to the Fiery and the different types of colored objects on those pages. Be aware that we are reviewing a modern Fiery System FS200 in this video. These features are similar for several earlier versions of the Fiery, but if you have a much older Fiery product, some of these controls may differ. If you found this video, you probably have also found the two-page PDF that accompanies it. The first page of the PDF is being shown now. This page describes how to get to the expert color settings on the Fiery that we'll be discussing in this video, and also shares some tips and tricks for configuring Fiery color settings. In order to get to the expert color settings on the Fiery, the first thing to do is to go to Job Properties for a job in Command Workstation. From Job Properties, I can click the Color tab and then the Expert button, or from the basic color settings, I can also click the Expert button in the upper right corner. This brings me to the Color Input tab of the Advanced Color Settings on the Fiery. There are three tabs here. The second tab for the selection of the output profile on the Fiery, and the third for the selection of the gray and black processing settings. In the color flowchart that we'll be studying in today's video, we will also understand how three different general types of colors on the page are processed based on these settings. This includes CMYK color spaces, RGB color spaces, and spot colors that are often contained in page description files such as PostScript or PDF print jobs. Therefore, the color flowchart represents a total of 5 different types of color page objects that we need to understand the processing of. This includes device-dependent CMYK, which is to say CMYK page objects that do not have an associated color definition with them in the PostScript or PDF file. The second kind of color page object we may encounter is CMYK that is technically device-independent in that it includes an associated color definition, often an embedded ICC profile in a PDF file. Similar to CMYK, there are two types of RGB page objects I might find in a PDF or PostScript file. The first, RGB with no embedded profile, which is a device RGB space, shown here in the third column. And the fourth, RGB with an embedded profile, such as an ICC profile in a PDF file, which we show in this fourth column. The fifth column of the color flowchart shows the processing of spot color definitions that we find in page description files, such as colors for Pantone, HKS, or other named color systems. Looking at the default color settings on the Fiery, the first thing to understand about the color inputs is that for CMYK source, we specify a default profile. In this example, the ISO-coded FOGR 39L profile that's commonly used in Europe and other parts of the world outside the United States. When the ISO-coded profile is set as the CMYK default source, it will be used as the source profile for all my CMYK page objects, including those you see in the next two columns. If we look to the bottom of the color settings, where we set the default for RGB, in this case sRGB, has been defined as the source profile that should be used for all our RGB page objects. We have in this top section a toggle or control for black point compensation of CMYK. By default, this is enabled for CMYK conversions. Black point compensation maps the shadow point of the source to the shadow point of the output profile and is typically what we want to get the best contrast and shadow detail in our reproductions. Black point compensation is enabled by default for RGB page objects without any control, since there isn't any case where I would want to disable this for RGB. In some cases, we might disable this for CMYK objects if we are generating proofs. The rendering intent defaults on the Fiery are these: relative colorimetric for all CMYK. There isn't a specific control for this on the Fiery. There is a control for what's called the processing method. This should always be set to full output GCR to get the proper color precision for color certification and to get the right colorimetric appearance of the output. Regardless of how the processing method is configured, something like the relative colorimetric rendering intent is always used, and this is the right intent for CMYK page objects. RGB page objects have their rendering intent set in the RGB LAB section at the bottom of the controls, and as you can see by default on most modern Fieries, this is set to photographic, the right rendering intent for RGB. Let's start to look at changing these settings. The first setting we'll enable is Use Embedded Profile when present. Note that when I enable this for CMYK, the CMYK source objects that have an embedded profile, such as CMYK with the Grackle profile that I show for an example here, will now use that embedded profile for the source rather than the default set for CMYK. Similarly, when I set Use Embedded Profile for RGB in the bottom part of this dialog, I will now use the embedded profile for RGB that I find with any RGB in the page document. In this case, an example is RGB with the embedded Adobe RGB profile. We'll use Adobe RGB rather than the sRGB default. The other thing to be aware of is that when I change CMYK to Use Embedded Profiles if present, those files, or those page objects, will now be treated as device-independent colors, no longer CMYK. On the Fiery, we label this as LAB. So you can see at the bottom of the dialog, I've set the rendering intent to photographic for LAB. When I'm not using the embedded profile, I get the relative colorimetric intent with the default profile for CMYK with an embedded profile. But when I set Use Embedded Profile for CMYK, I get the rendering intent photographic that is to be used for device-independent LAB color, since that's how we're now treating the CMYK. To study this a little further, if I change the rendering intent to relative colorimetric for RGB and LAB, that now changes my rendering intent, both for the RGB sources and for the CMYK with embedded profile. The next control I have in the expert color settings is paper simulation. Enabling paper simulation on the Fiery causes the rendering intent for CMYK to be changed from relative colorimetric to absolute colorimetric. This will result in the paper white of the CMYK source profile being simulated on the output. We will print dots in non-image areas to simulate the color of the paper that the CMYK source profile has on it. The only reason we would want to enable this is for a proofing workflow where we're trying to simulate the appearance of some other press on our output device. For production printing, we never want to enable paper simulation since it would be very difficult for us to sell prints with dots in non-image areas. The next control we have is the PDFX output intent. When I set PDFX output intent, we look in PDFX files to see if the output intent tag is present. If it is, this output intent can contain an ICC profile that is specified to make the PDFX file look consistent no matter where it is viewed or printed. If we want to use the output intent of PDFX for this kind of processing, when we enable it, we'll switch the source profile for our CMYK page objects to use the ICC output intent profile. Usually this is something like swap, where we say we want the document to look like swap on every screen and every printer that it's ever printed on. If we want to be fully compliant with the PDFX output intent, we also need to enable separate RGB LAB to CMYK source. This causes the RGB and device-independent color spaces in the third and fourth columns to be converted from their source space into the ICC profile from the PDFX output intent before they're converted into the output profile. The control for spot color matching is enabled by default on the Fiery, and the spot color control tells the Fiery to use a custom spot color table that it has generated for all the color libraries that are loaded, such as Pantone, Coded Plus, and the others, based on the output profile. This is the best way to get precision of spot colors on the Fiery DFE. If I disable spot color matching, the spot colors in my job will use spot color definitions from the source document, which may give a good simulation of the spot color, but are not going to give a precise match to the exact thing we might see in the Pantone fan book for a color like a Pantone Coded Plus. The next tab in the Expert Settings lets me control the output profile for the Fiery. In this example, we've set the output profile to use Fiery Demo Coded, and you can see that that output profile is used for all the conversions of CMYK and RGB before we print. This is in fact good for demonstration, but a very poor workflow practice. The reason is, if I manually set the output profile for each job that I print, I'm going to start to make mistakes. Different operators might pick different output profiles, and when we print a job and reprint it later, it might be difficult for us to remember which output profile we need. Remember that for the best color precision and the most success with our Fiery-driven press, we should really be making custom profiles for each of our different paper types and print settings. Once we have a few of these profiles, manually selecting them becomes even more complicated and likely to cause errors. For this reason, the recommendation is not to manually select the output profile, but instead to configure the output profile to use media-defined profiles. So this can be chosen either here in the Fiery Expert settings or in the basic color settings on the Fiery. If I set Use Media-Defined Profiles, now I will get automated profile selection. Let's take a look at how the automated output profile selection works on the Fiery server. The first thing we find out is if in the job properties, Use Media Defined Profile is set for my job. If we set this in the server defaults, Use Media Defined, then I'll always get this for all my jobs. If Use Media Defined Profiles is set for the output profile, the next thing we need to find out to determine which output profile will be used is to find out if the job uses Paper Catalog. Paper Catalog is accessed in the Media tab of the job properties, and it's a very easy way to set many characteristics of my media, including the paper type, weight, and size. If the Paper Catalog is in use, then the profile can be selected from the Paper Catalog entry if one is assigned. We can see the Paper Catalog entry in the Device Center of the Fiery under Resources, and we can see that for this Paper Catalog entry I selected, at least the front side of my sheet will have a specified profile used, this plain number 1 profile. If the Paper Catalog is not used, and some Fieries don't have the Paper Catalog, then the next thing to find out is if there is a profile assigned to the specific paper type or media type that I've chosen. So in this example, in the Device Center of Command Workstation, under the Resources Profiles, I can look at each output profile and I can see if there's a media type assigned. In this example, the Fiery Demo Plain profile is assigned to the plain media type. When I print this job, if I go to the Media tab of Job Properties, and rather than using a Paper Catalog entry, I pick a paper type, in this case choosing Plain, in this case, the output profile will be chosen based on the paper or media type, and the output profile used will be the one assigned to that paper type that I printed on. This is also the case if a profile is not assigned in the Paper Catalog. In this case, we'll go check to see if there's a profile associated with the paper type that the Paper Catalog specified, and if there is, then we'll use the output profile associated to the paper type. If no profile is assigned to the paper type, we'll get the color default profile for the server. Okay? This is where we start to get into the area where it becomes uncertain which output profile was used for which job. The other example of this is if we choose to manually select output profiles rather than use media defined. In this case, we always get the output profile we selected in job properties, but as we've mentioned earlier, it becomes difficult to keep track of which output profile we used with which of our jobs and paper types. The third area of expert controls in the Fiery Color settings is for gray and black processing. Gray and black processing refers to page objects that appear to be grayscale. These are pages that normally we would expect to have a black and white, not a color click charge for. But there's two problems with these kinds of pages. First, the grayscale objects may in fact be made up of RGB. And RGB gray is any case where we have red equals green equals blue in the RGB channels. It looks like it's gray. You probably estimate it for the customer as if it's a black and white page, but when it prints, because it's actually a color page, you can incur a color click charge. To solve this problem, set the gray and black processing on the Fiery for RGB to text and graphics. This will take any text or vector graphics page object in our PDF or PostScript document and use black only to print any pixels where red equals green equals blue. This is a very safe choice for text and graphics. We would not recommend choosing images for RGB since there are cases in images where neutral pixels occur with red equals green equals blue color channels, and we don't want those to drop out and print as black only. For CMYK gray objects, these are defined as page objects that have been perhaps accidentally built as CMYK with 0% cyan, magenta, and yellow, but some value in the black channel only. If we turn on gray and black processing for CMYK, and as you can see here we recommend you set this for text, graphics, and images, then anytime the Fiery encounters a page object that uses black only, even though it might be a CMYK object, we'll print this as black only, giving a black and white click charge rather than a color click charge if that's what all the objects on that page are composed of. There's one other case of printing gray or black using black output only to keep the black and white click charge, and this is when I have solid black. So this might be a CMYK page object that has 0% cyan, magenta, and yellow, but 100% black, or it might be an RGB page object where red and green and blue are all equal to 0. For these types of page objects, if I turn pure black on in the Fiery Expert Color settings, these objects will print as 100% black only on the output. In addition to keeping these objects as 100% black, I can also enable overprint for these pure blacks, and we recommend you set this for text, so the text objects will be overprinted, eliminating trapping problems and giving you a better overall appearance of that solid black. Other choices for solid black is I could set this control to use rich black, which would cause all these cases of pure black in the source document to print as 100% black plus 40% cyan. This is a good trick to use if I have pages with large black areas of fill. They come out looking gray or too light. Putting that support screen behind the black of 40% cyan, if our designer hasn't done that, is one way to give a more even and dark appearance to large black regions of the page. Finally, I could disable processing for black text and graphics by setting it to normal, in which case the solid black page objects, whether RGB or CMYK, will be color managed into CMYK output. This is probably not going to give as good an appearance as printing 100% black, and as we said earlier, this will result in a color click charge. Before we go through the best practice settings we recommend for your Fiery, I want to cover one other section of the color workflow diagram. If you look at the bottom of the flowchart, there's a box that says Calibration. We haven't showed you anywhere in this video how to pick the calibration, and the good news is you don't have to. The calibration is tied to the output profile which is selected, and when we make custom output profiles, especially using a tool like Fiery Color Profiler Suite, we naturally make a calibration set that is linked with and used with that output profile. The single most important thing you can do for your Fiery, in addition to configuring the color settings correctly that we've shown you in this video, is to calibrate it on a regular basis. This probably means on a daily basis ideally, or at least on a weekly basis, using a spectrophotometer like the ES2000. Remember also that on most modern Fieries, we create calibration sets for each paper type, so you should probably calibrate on the actual job stock you're going to print on before you run jobs on that stock. Let's look at the best practice settings for the Fiery Expert color settings. The reason we show this, and you'll find it on the second page of the PDF you may have downloaded, is because in this video we went through and turned on every control in the Expert color settings. If you were to do this, you'd probably get some very unusual and maybe not very acceptable results, since each of these controls has specific applications for specific types of workflows. For most commercial print production workflows, to get the best possible quality from the Fiery, we recommend these settings. First, set the source profile to the common CMYK working space in your region. This is probably Grackle or SWAP in the United States, or the ISO coded profile in Europe and the rest of the world. We will leave embedded profile processing disabled for CMYK, since CMYK is not always properly color managed. It doesn't always have the right profile assigned to it, and also because in order for our black and gray processing to work perfectly for your CMYK, we don't want the embedded profiles to confuse the color management system. We'll set the processing method always to full output GCR for the best colorimetric precision and the most pleasing color printing results on the Fiery from CMYK sources, and we'll enable black point compensation as it is by default, so that even if we have a light black point in a source, such as a newsprint CMYK source, we'll still get a very good looking reproduction of it by virtue of the black point compensation. We'll leave paper simulation disabled, since we're not proofing and we don't want dots in the non-image areas. We'll also leave PDFX output intent disabled. Remember, as I said earlier, this can cause overcompression of your RGB source data, and unless you really know you're printing PDFX files that have to comply in every way with the PDFX specification, we'd suggest you leave this disabled for your primary workflows and perhaps create some separate workflows or hot folders with the PDFX settings enabled for those specific jobs. For RGB, you will again set the default source to the one that matches your working space or that of your customers in Photoshop and the other Adobe Creative Suite applications. Probably this is sRGB or Adobe RGB. If you really have no idea here, sRGB is the safest choice since it's the color space that most digital cameras embed in the photographs that they capture. For RGB, we recommend you enable to use embedded profiles when present for the same reason that most of the RGB data today comes from digital cameras and has the proper profile embedded by the camera. The best rendering intent for RGB is going to be the photographic rendering intent. This gives us the most natural and best appearance for photographic originals and all the other originals that we find in RGB color space. Spot color matching should be left enabled, as is the default, for the best precision matching named spot colors such as Pantone colors in your input documents. The output profile should be set to use media defined. Let me review here that the real best practice is to set use media defined, and then rather than even trying to assign profiles to media types, use the paper catalog. Remember that if you're using Fiery Color Profiler Suite to create your calibration sets and profiles for each paper type that you use, if when you're creating the calibration and profile, you choose a paper catalog entry, Color Profiler Suite will actually populate that paper catalog entry for you with the profile that it creates for that paper. For gray and black processing, we recommend you set RGB to text graphics so we don't drop out black-only pixels in RGB images. And we recommend that you set print gray using black only for CMYK text graphics and images to make sure that you get black and white click charges for what appear to be black and white pages. We recommend for solid black that you set pure black on to get 100% black only output, and that you enable overprinting for pure black text. Thank you very much for your time in watching the video today. If you have additional questions, we encourage you to submit them on the Fiery Color forums, which you can find on the internet. Thanks again.